I'm here with Adam Chapman from Heat Geek, and we're back at John's dodgy heat pump install, if you like. This was the one where it wasn't working, it was costing him a lot of money, and then Adam came out to have a look at it and see if there was anything that he could do to help. And what happened after that, Adam?
Our Heat Geeks all saw the video we did, and it was obviously agreeing with what I was saying, and they were desperate to show you that this thing can work, even though it's a single skin brick building, and a much older building. I think this is 100, 150 years old, something like that, this house. They were so desperate to show you that they've all volunteered to come out and put this thing right. We've also had Vaillant donate a heat pump, Newark copper cylinders donate a cylinder that was designed by Heat Geek, the most efficient cylinder on the market with a heat pump right now. A team of us have come here today, self-employed engineers off their own back, so they're Heat Geek certified, they're part of the Heat Geek network, but these are all business owners who have taken some time out of their own work diary to come and help John out.
What we want to see is whether this works. Now, we're going to monitor this system. It's going to go online so that everybody can watch it. They can see exactly what it's consuming.
We, as Heat Geek, guarantee their work. That's how much faith we have in them. So we're going to guarantee that they have this specific system has a SCOP or efficiency of 3.9 or 390% efficiency minimum. I think it will be quite a bit higher than that, but that's the minimum SCOP that we're going to guarantee. If that doesn't happen, we will either replace everything, put it back how it was, but more likely we just adjust radiators, pay for more insulation, whatever was needed. In reality, nothing's going to be needed. I'm very confident. We've done hundreds of homes now. We've seen it over and over. And this is going to be monitored by third-party monitoring as well, not just the Vaillant monitoring that's in the heat pump. So that's been mid-certified. That's within a very small tolerance of inaccuracy, and available on the Skill Builder website for anyone to come along and scrutinise and look and check that it works.
Now, when you watch this video, you will see that they are keeping the gas boiler, and all the Heat Geeks have said you won't need it, get rid of it. We've done loads of these and you do not need a gas boiler. The clients have had such a bad experience with heat pumps and it not working, and all the problems with reliability, that they are absolutely adamant that they want to keep that gas boiler in place as backup, at least until they're absolutely sure that they've had a year of running the heat pump and they're happy with it.
Who could blame them? Every engineer they've had in here to do the same thing has said the same as me, sounded and looked the same as me. So you can't blame them for it. All the guys are a bit gutted that it's been left in, but I can't blame them either. Yeah. So it's the right thing to do.
Okay, first step is to get your base in for the heat pump, and you can just chuck it on the ground. I've seen loads of people doing that, but I don't like it because a lot of the time you find they don't take care of the drainage from the condensate, and that spills all over the path and then it freezes. I like to do the job properly, and that means getting the drawing. I did say rather morosely to Adam last week that I needed a drawing, and sure enough he sent me the drawing. That's on the instructions for the heat pump, and it gives the precise measurements for everything. Now, we've got a drain here that goes down directly below the heat pump, and that goes basically just into the ground. We've got some rubble down at the bottom to catch it, and that's just going to sit there and drain in. Now, funnily enough, when I was digging down, it's 600 millimeters down, that's 2 feet, to avoid any frost, any freezing. So the water will drop straight down to the bottom. And then when I was digging down, I found that I didn't exactly hit, but I found the drain, the main drain that's running all the way through. That's covered in pea shingle. So this is gonna sit on top of that main drain in the pea shingle with a bit of rubble, and it will just basically drain away and it'll run down the pea shingle. It will never flood. That's it, I don't need to do any more. Just get these bearers in and I'm done.
Drain off. Oh, you're having a bubble.
You need another set of these. Straight over a gully, mate.
Oh, I'll open that up, shall I? Look at the size of it.
Yeah, it's ridiculous.
Look, you had all this going into that indoor unit, with that going through it, back into here, into 28, with a glycol.
Yeah. That's your clearance. Perfect.
So what we've decided to do with this installation, as we said previously, ideally you don't want a buffer. Sometimes you have to put in a buffer. This is a bigger system, so more likely to need a buffer, but we're not putting one in. All of our flow and returns throughout the house come to this point. We have 2 flow and returns up there and a flow and return down here for the underfloor heating manifold. Every time the flow splits off down a different circuit, the flow rate reduces and the pump inside the heat pump can reach further. So it's less likely to need a buffer. It's the most efficient way we can install it without a buffer.
Where would you know when you find out when you need the buffer is when you're cycling or what?
When you first turn on and you can't balance the radiators. If we're struggling to get the last radiator up to temperature, get enough flow there, we've not got enough pump head, because there's too much flow there's not enough pump energy trying to push to the far radiator.
The difference between head and flow here, isn't it?
Yes, so pump pressure
is different to
exactly. They're linked though. The higher the flow rate, the more pressure you need to push against it.
The higher the flow rate, the less pressure you've got.
Available spare, yeah, exactly. But because they all come back and converge here and they sort of run parallel rather than in series, it can reach further, if that makes it. You've got less flow going down each leg. We're going to go without a buffer, and I'm pretty confident that'll be absolutely fine. 2 flows and returns upstairs, and it's 28mm as well. So there's a lot of open area to just push all this water down, which makes me think we don't need that, and we're probably fine for volume as well. We're stripping all this out. All this extra stuff we're getting rid of. We're getting rid of parts on this manifold here that we don't need, the blending mixing valve and the extra additional pump. We're going to keep it all in case for some reason over the last 500 installations these guys have forgotten how to do their job in much harder situations than this. We're even going to plumb this boiler back in and just valve it off, so if we need to we can turn back on the boiler. So you'll see much less stuff installed here. There's no point in throwing it in the bin. You may as well keep it in the wall because it can serve a purpose. So this is being plumbed back in to account for that, so we could switch off the heat pump if it ever did break down and he's got temporary heating. If you remember when we came back to John's house previously, we talked about points of mixing where the hotter flow can get mixed with the return and effectively dilute the flow temperature and cool down your sort of flow to your emitters or your radiators. So here is one of those examples. It's the underfloor manifold for this bathroom where we've got a mixing valve, a blending valve to blend down any flow that's too hot from the heat source. We're taking that out. It's just not needed if you're producing a lower flow temperature, and it means that we don't get this mixing which reduces efficiency. So we're effectively connecting our flow and returns directly into the flow and return pipe that goes around the underfloor here, and by doing that means we can turn down our flow temperature from the heat pump, which drives up the efficiency. Effectively, we're simplifying the system. We're getting rid of things that could go wrong. We're getting rid of a pump that draws energy and valves that could break over time.
That would normally be necessary. If you were running a boiler, for example, you would normally have that mixing valve in because you wouldn't want the temperature of the water to be so hot under the floor. So normally you'd lower that down. What you're saying is with the heat pump, because you've got a lower flow rate, no need to turn it down because it's already turned down. It'll come through. What's your flow temperature going to be? Target flow temperature on the heat pump?
We're probably going to be about 48, something like that on this system.
So
yeah,
that will be basically what you'd be aiming for on that mixing valve. Yeah.
Yes, and like if you get flow temperatures too high, you can end up with a cracked tile floor, exactly like this one's got. This was affixed to old sort of type systems, high temperature systems, where in the UK we wanted to adopt, or throughout the rest of Europe, we wanted to adopt underfloor heating, but we had these old high temperature systems, so you had to fit the valve. Really, for a efficient boiler, a boiler to be maximum efficiency, it wants to be down at 55 degree flow temperature anyway, which means you don't need the mixing valve again. Really, they were provided for non-condensing boilers. We've moved to condensing boilers since then, but we didn't ever update the manifolds.
We didn't design systems for condensing boilers. So now the new building regs are saying that all heating systems that go into new build have got to be low temperature.
See, that is exactly true. Although we didn't design them for low temperature, since we've gone and put in loft insulation and double glazing everywhere, actually we can have them because we've designed high temperature systems, then we've insulated the house, which has actually made the systems probably capable of being low temperature because they lose less heat without changing the radiator sizes. Exactly. Provided you've got 200 mil loft insulation and double glazing. You wouldn't even need cavity to be low temperature in most systems. What we're doing is waiting for some
tools to come up, and then we're going to drain this section. Even though the system's drained, there's obviously water going to be collected in this bit. So, and then what we're going to do is we're going to take the flow and repipe it with a flow regulator on, and then we're going to put it onto the primary flow, which is this one, and then we're going to take the return back, and then we can adjust the flow up here to make sure that there's no excess. It just monitors it up to a point. By us taking all this system out, it's sort of revolutionised our efficiency. You know, we're not got two pumps conflicting and different on systems.
You mean you've done this before then?
Yeah, so we've done this quite a lot. Yeah, we take out all the extra pumps that you just don't need on the system because we're using the heat pump to pump it round.
And more crud going in the bin. Lovely, cheers, mate. Thank you. Who's having all the scrap, or are we fighting for it later? Oh, top banana.
You're too. We'll taste it first, mate.
Wet and warm.
Yeah.
Oh shit, I'll throw it all down myself. If you get one that leaks, and you go back to the manufacturer, they take it apart, it's not deburred, invalidate. If you haven't marked it to the depth of the fitting and put an arrow on it, invalidates the warranty. Some of these, the cheaper ones, you can't then, you've got to get an angle grinder out and sort out the thread on it. The decent ones cut really well.
A little bit more water out.
Oh.
So has it been hard to resist doing the work today for you? You want to jump in?
Not one bit. How do you maintain your enthusiasm? Because you got here first this morning.
I did.
You have not stopped. Everyone else has the bacon roller. You love to drink tea. I've noticed that.
Yep.
You haven't had enough of it.
Not yet. Not even close.
But how do you maintain your enthusiasm for this job? Because it seems to me you're up for it, you're going for it, and tomorrow's another day, isn't it?
Well, with years and years of going out and looking at bad installs and all the rest of it, when you put one right, you get a lot of satisfaction from putting it right.
Do you do a lot of putting right?
Oh yeah, yeah,
Do you?
yeah. An awful lot of it, especially in this game where so much of it has been put in wrong, and there's such a bad name for heat pumps and the like. To actually put it right and rip out a ton of stuff and make it work, you do get a lot of satisfaction from that. A big part of this job is getting rid of the tyre figures because it wastes a lot of your time. The online quotation builder and stuff, it gives them a pretty good idea of the costs involved before you go.
Yeah, so you're price conditioning them really just
Yeah.
make sure that they're...
Yeah, because when you get all this octopus, British gas malarkey, we can put it all in for £8,000, so it's going to cost you 500 quid. That's just not right. And then they expect you to be pricing the same. And when we're putting in these cylinders and we're putting in these controls and these three-way valves that cost a lot more money, but you're going to get that money back relatively quickly. You're looking at costs of 4.2 and above as opposed to 2.8. So you are getting your money back. The monitoring system we put on will prove a lot, because you are physically showing someone what the system's going to do.
It's interesting because we took that cylinder out this morning.
Oh yeah.
And Dylan said to me, I can't understand it, you've taken one out, you've put another one in, it looks the same.
No, the coils inside these cylinders are twice, if not bigger than that for the one that we took out. It's got a monumental sized coil inside it, so the heat transfer is really, really good.
we got rid of the old heat pump because of the noise issue and the bearings damaged. We've replaced with our standard unit, this Vaillant Aerotherm Plus 12 kilowatt, which will produce up to 13 kilowatts of energy when it's -2 outside, so the depths of winter, which we know is big enough to heat the home. If it wasn't, we've guaranteed the job. We would have to do something about that, and also gives us access to additional monitoring and things like that. These are some of the best units we offer because of the way you can control them. So they have the best type of weather compensation.
Is that weather compensated inside?
It's kind of half inside, half outside. You have a heat interface unit, the unit on the other side of this, a heat pump interface unit, on the other side of this wall that speaks to the heat pump, and it's kind of done in there. And then you have an additional thermostat controller if you want to use that, or user interface on the inside of the house where they can turn up or turn down the temperature.
Yeah, they talk about not putting on a south-facing wall, that weather compensation, yeah?
Yes,
it
they
picks
do,
up too much. So
yeah, because if you heat the wall, if it's on the wall and that wall's heated, you'll get the heat being picked up.
Yeah.
But so you ideally want it on an unshaded or north-facing wall.
So that's what this is around here. So a lot of people said on that first video we did about the fence, they didn't like the fact the fence was so close because you're going to have air blasting out here, and they're saying it'll go over the neighbours and it can recirculate. What do you think about that?
This used to be a very big concern of mine, of air. This is trying to cool down the outside environment and heat up the house simultaneously. A big paranoia of mine was air being cooled, recirculating, and going back in colder, and you end up with this ever declining sort of spiral. I did a bit of experimenting with that, not fully conclusional. We used a smoke pellet, and I found actually the coolness kind of just dissipates up into the atmosphere very easily, because heat does move from hot to cold or cold to hot, so it ends up replenishing naturally. There are scenarios where you do need to be careful with certain shaped alleyways, but generally this is not something I'd worry about, and I keep on feeling wind pouring through this.
Oh, this is the wind tunnel for sure.
Yeah.
So just for those who don't know, what's basically happening is that air is being sucked in at the back. Now, hopefully that air has got some heat in it, and they're saying, well, down to minus whatever, there's heat. So there's useful heat to be taken out of that air. Obviously, the colder it gets, the lower the efficiency, if you like, but it's sucking the air in through here. There's a heat exchanger in here, and when the air comes out of here, it is an icy blast. Even in the summer, you feel it's decidedly cool. So this is the point about leaving 200 millimeters at the back, which meant this had to be further out, but also leaving enough room at the front for that air to escape and do its bit. It's all on the instructions, you've got to do that. The other thing that was quite interesting was that you've got to keep it away from opening windows as well. That is to do with the refrigerant, is it not?
Modern units, and these units that are more efficient than the older units that are around, are using propane refrigerant, which is a flammable gas. Some say highly explosive. There's about a coffee cup full of propane in here.
Is that all? Really?
Yeah, much less than you'd have in a barbecue or anything like that. But because of old regulations, we have to keep it as far away from these doors as possible, in case that one coffee cup all goes inside that house, and then there's a spark inside the house. Yeah. So I don't know how long those regulations are going to last, but they're in the way at the moment, and it prevents a load of heat pumps from going in sensible places. This industry is still in its infancy, even though they've been around for years.
Yeah.
There's things in planning that are crazy. There's very strange noise assessments. The size of the heat pump, physical size, has to fit within it. It's all stuff to come out the wash, and it's all being consulted on at the moment by government, because the government's basically decided this is the way we want to go.
Now, it's interesting what you say about noise, because apart from anything else, the reason John turned the heat pump off was because it was keeping his neighbour awake at night. It's a terrible screech coming out of it. His neighbour is actually going to come round and have a look at this today. He's actually an engineer, retired engineer. He's interested in it. And John's saying to him, it's going to be quiet, and if it's not quiet, we're going to turn it off. You know, he's not going to fall out with his neighbour.
Absolutely.
He loves his neighbour. It's great. The neighbour's going to come around and listen to it and see it working.
The neighbour literally had to move bedroom, so I'm under a lot of pressure for this to work. I want him to move back into his bedroom, ideally, and it's all on camera, and the pressure's here. So let's. I mean, I don't need to hope, but let's hope it does work.
Beautiful, at last, and at least Adam didn't make it. Lovely.
You're doing heat pumps now and nothing else, or what?
Pretty much, yeah. Yeah, for the last 18 months now, I think I've done one gas boiler.
So you've always been heating, not plumbing?
No,
You
don't touch plumbing. Never touched plumbing in my life. Because there's too many people out there that call themselves plumbers, and then it's a race to the bottom. Pretty much all heat pumps now. We do a lot of big refurbs, so by the time you factored in the zero VAT and the bus grant, it works out cheaper. If you're doing a new build or a new big refurb and you're putting in a new heating system, you've got to design it to 55-degree flow anyway. Your heating system is pretty much the same regardless. So you then take your VAT out of that, which you're saving on the job. You've got underfloor heating predominantly all going in downstairs, so you're saving on that. You're getting your bus grant back on it. So
when you say bus grant, boiler upgrade scheme, for those who don't know what it is,
you're getting your £7,500 back on that. So it actually works out a bit cheaper. Yeah, it's good to get involved in this sort of one. More just like proving people wrong. You can see the amount we've taken out in here. Barring the cylinder going back here, this is kind of it. And beforehand, you had a whole ton of stuff in here that just wasn't needed.
So, Tom, if people want to get hold of you, if you're interested in hiring you for your heat pump?
Just don't. We get emails galore every day, and social media, not a big fan. We've got enough. We've got enough. You can get hold of me whenever you like.
You want Tommy's services, you've got to know somebody. Put your kid's name down now.
Why is there so much stuff left over then?
Because this is surplus to requirements. It's simplified the system, basically. Simplified the system by taking out probably £1,000 worth of kit.
Yeah.
Easily, actually, because they got that and the buffer. So it'll be £1,500 worth.
With the whole heating system coming off 28. The more that's kicking out that way, see the elbows going?
Just like the cavalry, Simmons turned up from Urban Plumbers to have a snoop around when all the work's almost done, and he's brought Marie, who is his assistant, apprentice. Is that right? What are you, apprentice or
Apprentice, yeah.
Yeah. I've seen you on the channel doing all the
She does most of the
press
work.
fit and so on. Yeah. While he disappears somewhere to chat to the customer.
I don't really like chatting to people.
But yeah, he's got a great channel. If you want to watch that, check it out, Urban Plumbers. He takes on all kinds of jobs which more sensible people would leave. You're moving into new installs because there's so much of his stuff.
New installs are easier because you can start from scratch. You don't have to unpick others people work. That's it's interesting and resolving puzzles and stuff. But who has time for that, right?
Anyway, it's good to see you at last because I know
nice
you've given
to meet
me
you.
loads of stick. I'm really happy to have criticism. I know you believe that heat pumps are good for everybody everywhere.
That I believe,
if they're designed right, yeah?
Yeah, every house in UK can have a heat pump.
Yeah.
Might not be cost effective for everyone, but it can be made to work in every single house.
A lot of people just haven't got the room for a cylinder. They're on a combi boiler.
Correct.
If you take out a combi boiler and you put in a heat pump, and what do you do about domestic hot water? And Adam and I have had this conversation on many occasions, but I'm still persuaded. Funnily enough, talking to the guys yesterday about air-to-air.
Yeah.
And I think there's something going on there which people aren't exploiting because quick and easy to put in. They do a job. They may not be the most efficient. They may not be most convenient, but for a lot of people, that would be.
Yeah, that's probably the
way to
cheapest
go.
way to remove yourself from gas.
And a lot of people, when they watch our channel from abroad, they go, I can't understand you Brits. Why are you doing air to water? They don't understand, well, we're even going down that route.
She had a drawer in her house.
Yeah. Any good?
Quite good, yeah. A bit noisier though. Like
Is it?
The outside unit is a bit noisy.
Because you had Mitsubishi, that's why.
There you go.
Yeah, that's the sponsorship gone.
That's another one. Anyway, it's good to see you last, and keep giving me stick, all right?
long as it don't leak. If it don't leak, it's all right. Unlike whoever done them ones.
Okay, this is the sound test then. And you're telling me that's running flat out?
That is at the moment charging at around 2,000 litres per hour on heating mode. Both fans are running. That is now kicked in for hot water, so this is as much as this is going to go. This is going proper flat out now. So we're looking at 12 kilowatts, full on compressor, 100% virtually. And that's it. The rain's noisier than this.
Yeah, yeah. That's fair enough, okay. No, you know, that's a remarkable. And do you know why I think that is? Because the bass was so...
Oh, without a doubt. The bass solves all the problems.
Okay, so here I'll just explain to you how we've optimised the system and we've matched the heat pump up to your system design.
Yeah.
So here we're going to go into install level, but you won't have to adjust these settings. I'm just giving you an explanation so that you understand how it works. Now, if we go to installation configuration, and we'll go to circuit 1, this is your heating circuit. And we can see here we're in heating mode now with a target flow temperature of 40 degrees. We've got a heat curve of 0.8. This 0.8 is telling the heat pump what size, what flow temperature we need when it's a certain temperature outside.
Sure.
So we've sized these radiators for around 50 degrees flow temperature at -2 outside. So that matches up with around heat curve 0.8. So, and that then will maintain the internal temperature of your house at whatever no matter what the outdoor temperature is.
Yeah.
If it gets cooler outside, the radiators will get warmer. If it gets warmer outside, the radiators will get cooler.
It's the latter bit is the bit I need to know.
Yeah, so it maintains a steady room temperature.
Yeah.
And it always operates the heat pump as most efficiently as it can, because the lower the flow temperature, the more efficient the heat pump is. And the number one thing you can do to increase the heat pump efficiency is to get the heat curve right. So we carefully match it up to the heating system design. And if you ever feel it's too warm, let us know, we can adjust that. But mostly once we've set it, and that's it.
Can that be done remotely? The change?
Can be, yes.
All right, okay.
Can be. It's good. We'll check up on you in a couple of weeks. And
Adam Chapman's going to look,
So
Great. Okay.
Yep. And this, I particularly like on this how we can just adjust it so easily by. If we ever want to change the temperature, we've set all the time programs here. What times we want it, what room temperature we want at certain times. But to adjust it, all we have to do, press the menu button there, and we can just scroll it up. Or we can do a temporary boost. We can knock it up or down. We can press a tick, and we can just say how long we want to boost it for, to adjust it for. It's so simple,
it's a good one.
So easy to live with. We'll just cancel there. 19 degrees now, and it's warming up. It's so easy and comfortable and efficient.
Can you get BBC One on that?
Outside.
That's why it was 30 quid a go.
Did you enjoy that, Adam?
It's my first bit of manual work in 5 years. Absolutely loved it.
Yes. To defrost it.
Exactly.
Whoa! Oh, Dylan. What's the mean vase? Quick, where's the super glue?
Thank you for those teas and coffees from John. And I'd like to present you with a gift to make up for Dylan's clumsiness knocking out your Ming Dynasty vase Heat Geek mug.
Brilliant. Thank you very much.
Do you know
Not just installs.
What can one say? Where are we?
Heat Geek.
Sorry.
Renew the heating industry.
So what did I say? Heat pumps are a mugs game. So that's it, the heat pump is installed, it's up and running at last. Well, actually it only took a day and a half for those guys to do the whole job, and we've even insulated the loft to make sure that they get the maximum out of it for the minimum cost. So it's great. Just I do urge you, keep looking at the figures so that you can see just how much electricity is using, how much heat they're getting out of it. So Adam, it's been a while since we were in this little situation here, and I just want to say, what are you doing on Heat Geek? Because you and I are going to have a bit of a punch-up for 2024 Installer Live. The NEC now, isn't it?
NEC in Birmingham. We've got a theatre there. Me and you are going to sort this out, if heat pumps work or not, and if they're the right thing for the government to push behind and for homes to be moving to from gas boilers. Come and watch, and also we're going to involve the audience. Come and ask questions.
Yeah.
Ask us face to face. Like we're not pre-scripting anything. Me and Roger don't really get on very well regarding this subject, and you're going to see that live if you turn up. It might be quite entertaining.
And what we want you to do is come along and heckle. We don't want a tame audience sitting there falling asleep. We want you to get involved, shout out, and we'll have a roving mic going around. So if you've got something you want to add to the debate, you'll have an opportunity to do that there. And I think it's going to be absolutely great. You know, no blood will be spilt. We're still good, civilised people, but we do like to actually have a good old argument.